any part of the talk, you have already seen the cool part. So I'm going to show you that right away. And what I show you is a website that you can access. You can also see the URL at the top of the window. And what I hope is that you feel somewhat overwhelmed by this kind of model that you see here. This is a process model, and it is actually a description of the procedure that is being followed if you implement ITIL, and you have to deal as an organization with all kinds of issues, software issues. And this is the procedure which describes the different steps and also the conditions which are in force when you would deal with issues. Now, so this is a process model of a business process. Many organizations create and maintain these models. The research in a group is often focused on discovering these models automatically on the basis of data that users leave behind when they execute the process. But that is not the topic that I'm going to address today. Earlier, one of the people in my group, Cici Lu, mentioned process mining, and this explained her work here. I'm going to talk about something else. The starting point is that you already have such a process model in place, and you want to use such a model, for example, to explain people who will be new to the process what their responsibilities are, or how the process exactly unfolds when an issue happens. Or you can also imagine other use cases that you have a process and you want to explain to a third party how well you are dealing with their issues. For example, if you take care of that business for them. Now, these process models are rather complex artifacts. I'm showing you here a model which has maybe 40 steps, a little less perhaps, but we are also aware of process models in industry which have dozens or even hundreds of these steps. And then you can imagine that it's rather complex to, well, make sense of these models, especially if you have a very focused question or focused thing you want to know about the model, how to find that out. Okay, so what is the cool thing of this talk? What I will be showing you is work we have done to animate these models. And on this process model, I will turn the animation on so you also immediately have an idea of the things we do or we can do. So I'm starting a continuous animation of this process models. What you see on this side of the screen are two different ways to initiate the process. And when I select one of these branches, you see that the process is being executed. And even though you may not be familiar with the logic of this process model at all, you see the different paths that are able that you are able to follow. There are choices in the process, and once in a while I have to really make a choice of what's going to happen by clicking on things. But you see that the process starts unfolding itself, and by just following this animation, you get a better sense of the different paths which are available through this process model. And the key idea of the work that I'm going to present to you in the remainder of this talk is about this animation feature of process models. Okay, I'll switch back to a presentation that I prepared, which gives you a little bit of the background of this research. So I did this research, and I think that is the first thing that I should mention. I did this research together with Banu IJsselmas, and maybe I should say she did it together with me, because she is the driving force behind this project. Banu and I were working in Amsterdam at the Vrije Universiteit when we started this project, and that is already some time ago. We started working on this in 2017, and Banu has at that time had a Marie Curie fellowship to work on the animation of process models. And I'm happy that she's also here. That always helps when you get really tough questions. So we already were aware at the time that animation is a powerful technique to explain things to people. Animation, for example, is a technique that is often used in instruction of complex systems, and even systems that do not seem very complex, like, for example, a toilet tank, are much better understood when you explain them to people by not showing them static pictures, but showing also how these different elements, how they work and cooperate with each other. So one of the papers we also cite in our work is actually a paper that explains how you animate visualizations of toilet tanks. So it's amazing where research brings you, I think. So even though we had the idea of quite early on that animation could be an interesting technique to also apply to process models, you cannot just start building it and then hoping that everything will be okay. It would be a huge waste of effort to start building such a feature if you don't really have a good understanding of how that should exactly be approached. So what we did is we thought of these complex process models. We know a lot about these process models, and then started investigating some theory. And there are two important theories that we use to build a sort of a foundation for the work we did. And I'm showing you two of the books where we got a lot of our, let's say, background knowledge from for this project. On the one hand, we used cognitive load theory to better understand what exactly the mental challenges, the cognitive challenges are that are incurred by process models. And I'm telling you a little bit more about that. So that is, let's say, the things that make it hard for people to read these process models. And we started to read more about multimedia learning, so how people use animation in other contexts, to see what the strengths of animation are, and in what sense they could help to overcome particular challenges. So we analyzed these things and came up with a sort of a connection between, on the one hand, challenges. Let's see if I can bring up my pointer. I'm sorry. Challenges, on the one hand, that are imposed by reading process models. For example, there is a very nice example. Oops, maybe I clicked the wrong one, I'm sorry. There is a very nice example that process models are very well known for all the hidden dependencies in those models. So when you see something in a model, you do not immediately understand what its relation is to another component in that same process model. And that is known as a hidden dependency. But exactly, animation has a facilitating function that you can impose on top of an object, like a process model, additional facilities like color, like movement, to make those connections visible. So what we did is, in this work, we mapped all these challenges and tried to match them with animation features. And in this way, well, created a sort of a convincing argument, also a scientific argument, that we could improve the comprehension of these models using animation. So one of the things that we also learned while we did this project is that there is, even though animation seems like an attractive approach to improve the accessibility of objects like process models, we also found out that there's an interesting phenomenon which is called the expertise reversal effect. I hadn't heard of this effect until a couple of years ago, but it refers to the principle that the effectiveness of instructional techniques like animation, this can be reversed depending on the expertise level of the people that you provide the instruction material to. So to put that in more simple terms, the way you explain something may work well with particular users, but it may have the opposed effect when you use the same technique or the same explanation for users with a different level of expertise. So to make that a bit clearer, let's suppose you have a very elaborate explanation that would fit very well with people with a low level of expertise on a particular topic, like process models. You would have to provide a very comprehensive explanation, but this very comprehensive explanation would actually induce more cognitive effort for people who have a moderate or high level of expertise. You would try to provide them with a different type of instruction. So when we became aware of that particular effect and we started thinking about how this would pan out for process models, we understood that whatever we would do with animation, it should not be a one-of-a-kind type of animation. So what we took away from it is that the animation environment that we wanted to build should be adjustable, dynamic, and should also be configurable to fit with the needs of different types of users. So then the hard work started. And again, Banu is the person who did most of that work. She built the environment, which I showed to you. So she created a platform that was able to import process models, to visualize them, to manipulate the animation, and that was a lot of engineering work. So, in fact, I think this single slide of that platform doesn't do any justice to the effort that is really behind it. But when we had that platform, and even though we think it was quite well substantiated by the theories that I mentioned before, there was still, of course, the proof of the pudding. Would it actually help? So to test that, we set up an experiment, and this experiment, in the software engineering experiment, in the true sense of the word, involved a number of people. I will tell you about it. And what we did is we exposed different groups to different types of access to these kind of process models. So the thing that we wanted to investigate is whether the visualization of process models, and we had two levels, people who would just look at these static models, or people who had animation features available to them, whether this had any effect on the comprehension of those models. We measured that comprehension using a test score, which we also took from other researchers, and which was already validated, to see if people would be able to read and understand these models. And of course, since I mentioned that expertise level as an important element, we also included the moderating effect of process modeling expertise in this research. So this was our research model. Now, what did we show to people? Well, we asked them to take a look at process models like these and ask them questions like, if J is executed as a task in this process, can that happen more than once for a single case? So users would have to think whether they could see any cycles in the process, and whether J would indeed be reachable in such a cycle. Or we would ask questions like, if H is executed, can you then still do N at some later stage? So people would really have to make sense of the logic of all these arrows, and also understand all these gateways which were in between, to answer these kind of questions. Now, in the treatment groups, we provided people with animation features, so they would be able to use the feature that I also that I've shown to you at the start of the presentation, where they would be able to automatically animate these process models, or to do that in a more fine-grained manner, where they would be able to step through the process model, not in an automated way, but exactly according to their own preferences. So they could do their own investigation, instead of looking at a fully automated animation. And in fact, what we found out was that this difference, let's say the intensive, let's say the fully automated animation versus the step-by-step animation, was exactly the kind of different support that people with low expertise and high expertise needed. People with low expertise were fine with seeing the whole process model be unfold for their eyes. And people with high expertise were using the animation features to really figure out particular things that they wanted to know. So this was exactly the kind of dynamic support that we could provide them with. Now, we involved a lot of people, and that was a lot of administration, and was a lot of work of doing that. We had close to 200 people working with us in these experiments. We split them up in the groups who saw the static representation, and also got these, the static representation versus the dynamic animation of these process models. And we had a lot of more data about these people, but you can read more about that in the paper. Then the most important outcome of that experimentation was this, and you can see it in this figure. What you see is that we here split up the group of participants in 3 categories. The categories with people with low expertise, moderate expertise in reading process models, and high expertise. what you can see along the vertical axis were the differences in the test score when you would compare the scores they got when using the static models or the models with animation features added to it. And for everybody, we could see that the comprehension, the test score, went up when we gave them animation to play with these models. But you can also see in these models that the improvement of the test score was strongest for the people who had low process model expertise and people with high process model expertise. The people in the middle also improved their performance, but not that much. So this was, of course, puzzling, but it's also interesting. And it goes back to that phenomenon that we mentioned earlier, that we could clearly see that the experts like this interactive kind of animation, and people with very low understanding of process models like the continuous animation features, and people in between were probably were not helped very much by this automatic visualization or animation, but they also didn't know exactly how to use this more interactive animation to figure out the things that they needed to know to answer our questions correctly. So we thought that that was a very interesting insight. So to reflect a little bit on this type of research. So I liked it. I like to be involved in this project. It was published in a rather well-known and well-regarded journal in our community, Information and Management. And I think that it was tough, but I think that we were able to show in a very convincing way how animation helps people to make sense of process models. And when you come to think of it, but that's always at the end of a research effort, it makes perfect sense, right? You try to describe something with temporal behavior, and if you do that in a static way, it makes it more difficult than actually seeing the nature of the process that you wanted to capture in the first place. What is interesting, and I already emphasized this, is that experts and novices need different types of support. And I think that is a message, a takeaway that will also probably be valid in other, with the animation of other kinds of objects, or even the instruction about other kinds of objects. And something that was, I think, gave us much satisfaction is that the principles we applied can be easily adopted in industrial modeling tools. And in fact, I think I have seen on Twitter vendors of process models showing animation features, and you never can relate it back to your own work, but we see a lot of work being done there. And I think that's perfectly fine. I think that is, if that is the result of our research, that vendors think, oh, this is cool to be included and it actually works, then I think this is a very important result of our work. So that is, I think, those are some of the insights that I derived from working on this. There's also more of a personal reflection on this work. On the one hand, it was extremely satisfying. It was very much fun to work with Banu, and I hope she thinks the same about working with me. And I think that in this work, a lot of things came together. I learned a lot in a sense of getting to know cognitive theories. I know a lot about process models, and I know a lot about the formal analysis of these models. This is clearly another angle to these process models. I learned a lot, and I think we were also able to mobilize the important theories to, substantiate this work. There was a lot of engineering involved, which is, I think, closer to my home as a computer science engineer. So the development of the tool, that was, I think, interesting. There was experimentation. So that's one of our core instruments in science, of course. So I think it was nice that we were able to evaluate the effectiveness of this platform in a way which was thorough, and it has a lot of practical implications. So in that sense, this was a very satisfying project to be involved with. On the other hand, there was a lot of frustration associated to it as well. This was a project, we published this paper in 2021, and it is a project that has at least taken 4 years. Well, not 4 years of all of our time, but when I give a presentation of 20 minutes, it's impossible to convey the efforts we had to take to really carry this out in such a thorough way. So it has been 4 years of work, and in that 4 years of work, we've also spent a lot of time on writing, but also revising this work. And sometimes we were also desperate when reviewers pointed us to other theories or other experimental methods or other statistical techniques. But I'm very happy that we persisted and that we got to the point that this paper is published and that we are also able to, talk about this and that others can also build on this. So yeah, that is the perspective from my side. And at this point, I would like to stop the presentation and open the floor for any questions. Thank you.